I left some stuff on the board. Austin, erase that stuff up there for us so it's not distracting.
I didn't find it.
Okay, 3-2, day 2. All right, we're just going to do one, just like Fridays, except it's got a little catch to it. So we'll start off with an example right off the bat.
Whoa.
We're going to have 2 gears. You know what gears are? They got the little teeth that fit in with each other, and when one turns, the other one turns. You guys going to make it over there?
Yeah.
Okay.
Did you just hush me, Kenley? Seriously?
Whoa.
Okay, 2 gears. They actually touch. So one fits into the other one, so when one turns, the other one turns. This small one has a radius of 11.7 centimeters. This bigger one, our goal is going to be to find the radius. When this one turns 50 degrees, it makes the other one turn, oh, wrong one. This one turns 80 degrees. Sorry. Is this one going to turn more or less? Less. And it only turns 50 degrees. That's a bad 80. This one turns 50 degrees. Okay, so our goal is going to be to find the radius of the larger pulley, or gear. R2 we'll call it. Okay, the trick to doing these ones, when the 2 gears are stuck together, what is going to be the same? Think about the formula. What's our formula from Friday? Our arc length formula? S equals R times theta. So the distance that this point travels. So I know this point is going to make an 80-degree turn, so it's going to be up close to the top here. This one's only going to be about 50 degrees. But what is going to be the same between them? The radiuses aren't the same. The degree measures aren't the same, but what is going to be the same?
The arc length.
Yes, the distance traveled by both points is going to be the same. So the trick to doing these ones when they're stuck together is that the arc lengths are equal. So the trick is that the arc lengths are the same. The arc lengths will be the same. Can I find the arc length that this point travels on the small one? Do I have enough information there?
Yes.
Yes, I do. Once I find this S value, I can transfer it over to this one, because those 2 S values are going to be the same. So I'll have the S, I can figure out the theta, that will leave the R unknown. So over on this one, I don't know the S, but I do know the R, and here's my almost theta. So we can find the distance that that point travels. So did we figure out theta off to the side, or did we stick it in the formula right away?
We kind of did both.
Kind of did both. Okay, so S, we'll start with our formula here. S equals R theta. We're going to figure out the S. The radius is 11.7. The theta, well, almost theta is 80 degrees. What do I have to do to that to make it theta? Divide by 180 and then times by pi. So we'll go ahead and do that. You will go ahead and do that. We're looking at 3 sig figs. Is that correct?
I got 16 points.
You got 3 different answers
As
from
the
the...
answer, I got 16.3.
Okay, I got 1.4.
Okay, then what's going on? Let's see. You should be typing in exactly what I wrote down. I got 11.7 times 80 divided...
I didn't multiply by 11.7.
divided by 180 and multiplying by pi. Okay, so now we know.
Oh, I was thinking pi.
Oh, okay, well there's the, okay. So we wanted the distance traveled, so I did multiply it in. So it's 16.3 centimeters traveled. So that means on the other pulley, this point also traveled 16.3 centimeters. Looking for the radius, and I have my almost theta here. So we set up the same formula, S equals R theta. This time I know what S is because it's the same as the first one, 16.3. Don't know the radius. And my theta can be found by 50 divided by 180 multiplying by pi. So yeah, now we just want to do this part and then we'll divide afterwards. Point what?
28.73.
Sounds about right.
It is.
That is, then we'll divide. And you know you should be getting a bigger radius.
I got 18.77.
That sounds very reasonable. So 18.8. If we went 3 sig figs.
Sure. I'm sure we have.
Any questions on that one? Okay, so if you've got 2 things working together, arc lengths will be the same. That's the trick. New formula coming your way. 2 formulas in this section. Oh, no, not yet. Not a new formula yet. Okay, new vocabulary coming your way. Subtends an angle. That phrase. Subtends an angle. What it means is that, like I could say, let's see. I could say the Empire State Building from where I'm standing subtends an angle of 2 degrees. What do you think I'm talking about there? Kind of. Subtends an angle means you are at the center of the object, but far away from it. And you're taking an angle measure to the top and the bottom and adding them together. So you're at the center of an object, and it would be the angle from top to bottom. Top. So if I had the Empire State Building, oh, yep. Put an antenna on the top there. If I was standing way far away from it, from the center of it, I could take an angle measure to the top and to the bottom. This angle created here is, that's your subtends an angle, means it creates that angle from the top to the bottom. And what we're going to do to estimate is, if I wanted the height of this Empire State Building, I know the height is a straight distance, a vertical linear distance. But if I was far enough away and this angle was super small, this curved distance here for my circle would be a good approximation. So this S value, that curved distance, and this vertical height value, I'll use H for height, H is approximately equal to S if I'm standing at a very small angle. If theta is very small. Yeah, only if it's very small. So what they're going to do is use this arc length formula as an approximate way to find a vertical distance or a horizontal distance, a linear distance. So, big, you wouldn't use this as a good approximation technique. But if theta was really small, if you were far, far away from something and you kind of wanted to know how big it was, you could use this arc length formula as a good approximate for it. Like this next example I'm going to do.
Wait, how come you made the S thing?
Because we're going to use, because I have a formula to find S that's very easy to use, S equals R theta. So if I knew how far away from the object I was, and I could somehow pull out that magic angle measure from my back pocket and measure this angle, I can find out how tall the Empire State Building is by using this curved distance as its approximate value. So this is an approximation technique. So let's try one so you see what I'm talking about.
Wait. If theta is...
Okay. So example 2. I've got an oil tanker that's out at sea. Out to sea, that is out to sea, 2.3 kilometers. It subtends an angle of 1 degree 30 minutes. It's a very small angle. Can you approximate the length of the ship?
Let's draw a picture.
Let's draw a picture. So I need a ship. Oil tanker. No idea what an oil tanker looks like.
Let's just draw a ship.
Put some stacks on it. Here's my oil tanker. Do anything you want. Okay, my goal is to find out... Oh, you could have. Okay. All right, so our goal is to find out how long this ship is from the front to the back. And what they tell me is it subtends an angle of 1 degree 30 minutes. And it's out to sea 2.3 kilometers. That means I am the person that's 2.3 kilometers away. I am measuring the angle from front to back. So here's me. Yes, so we want front to back the length. Instead of the Empire State Building would stand tall, this is running this way. So, I am the center of a circle. Now, is my picture way exaggerated? Absolutely, because this is only supposed to be a 1 degree 30 minute angle. Super small. But it's okay. We're just blown up a little bit. So what I'm going to do, the distance out is 2.3 kilometers. Equivalent to about a mile and a half, maybe? I don't know. So our goal is, I know this angle is 1 degree 30 minutes. With those two pieces of information, I can find the arc length of a circle coming through here. Very good. See? So it subtends an angle means I'm at the center of the circle. If I find S, I'm going to say S is a good approximate for this straight distance across here. Is it exact? No. Is it a good approximate? Yes. So it's an approximation technique. All right, so we've got our radius, and we've got our almost theta. So we go right into S equals R theta. Radius is 2.3.
You call it almost theta?
Because my formula says theta has to be in radians. The real theta must be radians. I've got degrees. So that tells me, boy, I've got to do a little bit of work when I put it in my formula. So how do I get from degrees? Divide by 180 and multiply by pi. Oh, yes it is. Yes it is. Oh yeah, I got 2 there. Yep, that was bad. That's seconds. So how long is that ship? With, what do we have, 2 sig figs? 0.60 or 0.6?
06. Matt Casey.
06?
Yeah.
According to them, they got a lot of yeses. You see it? Okay, 0.06 kilometers. What do you think a ship would actually be measured in? What units?
Meters?
Well, meters, yeah. Like, this is comparing to miles. Would they give the length of a ship in miles? I don't think so. Probably feet. So
60 meters.
So how many? How do I move this over to get meters? Not that they asked for it. How many meters in a kilometer?
Just multiply by
1,000.
1,000. If I kicked it over, it's about 60 meters long.
That's a pretty small oil tanker.
Well, a meter's out next to a yard. So if you times it by about 3, that's about approximately how many feet. So now we're looking at 180 feet. So, is that big? I don't know. Okay, now the new formula. And the easier problem. Okay, area. So we found arc length on a circle. Now we're going to find the area of a sector.
Is this example 3?
Not yet. Of a circle. So if we have a circle, and we have a piece of pie, I would like a formula that would give me the area of this piece of pie. And for this, we only need to know 2 pieces of information. We need to know the radius and the angle measure. Okay, so what's the formula for the area of a circle? Pi r squared. Okay, that would be for the full circle. To get the area of the sector, which is a fraction of the circle, what is it? Pi r theta. You are almost correct. Nope. If this was a 90-degree angle, what fraction of the circle is that? 1/4 of the circle. If it was a 180-degree angle, what fraction of the circle is it? A half. If it was 270 degrees, 3/4. Because you know that 90, 180, and 270 are all a fraction of, how did you figure out that fraction? Like with the 1/4, the 1/2, the 3/4. Because the circle is 360. If this was in radians, what's a full circle in radians? 2 pi. So the fraction would be theta over 2 pi. So we're going to take the fraction, theta over 2 pi, and multiply it by pi r squared, and then simplify that. What happens in my formula here? The pi's cancel. So my formula for the area of a sector is theta times r squared over 2, but theta has to be in radians. So I'm going to do it in words first. It's radians times radius squared divided by 2. So it's theta times r squared divided by 2. So radians times radius squared divided by 2 gives us area. Okay, ready for the examples?
Yes.
Okay, here we go. How far behind are you guys? Okay. Betsy's okay?
Yeah.
Everybody okay? Don't want to lose anybody. There we go. So we'll start back with our easy problem. Circle. Radius is going to be 18.3 centimeters. Angle is going to be 125 degrees. Can you find the area of the sector? Yes, Austin. Same thing as if it's 125, or it's going to be the same process. Still going to be the same process. So we're looking for big A. We know what's the 18.3 giving me? Radius. And what's the 125 giving me? Almost theta. So area equals theta times radius squared divided by 2. So let's start with theta. I've got 125 degrees. What do I need to do to that? Divide by 180. Then times by pi. That's all to get theta. The next part of the formula says multiply that by the radius squared. Whoops, 18.3 squared. And instead of dividing by 2, what else can I do? Can I just multiply by a half on the end and call it good? Otherwise, to do all of that and say divide by 2. Whatever you like. So now it's just one big line on the calculator. Is everybody okay with my multiplying by half instead of dividing by 2? If not, then just put divide by 2. Whatever you like. So it's a pretty straightforward, basic problem, just knowing that you've got to convert degrees to radians. Is the what?
Is the sector, like in the circle, like what part of it?
We're finding this area here. Did I answer your question?
Yeah.
Okay. What was the answer to this question?
I have 365.
Oh, I have 139.
Did you multiply by the pi, Austin? What? Tell me exactly what you typed in your calculator. What did you type in, Michaela? Did you have the squared?
Yeah.
Times what?
Times 1/2. You added 8.
There you go. He put a plus in there. So again, what is it? 3?
365.
And then what kind of units would this be? There's area.
I have centimeter squared.
Oh, yeah. There.
It's gamble, so it's right.
It is correct. Okay, try another. Because it's area. Area is always units squared. Okay. if my area is 8, yep, 8 square inches, the radius is 4 inches, can you tell me what angle this was in degrees?
So it would be the times that 5 divided by 180.
Let's see what we got.
Wait,
What,
what's 8 inches squared? Is that
you tell me, what is 8 square inches? What is that giving me?
area?
That is area. This is big A. Big A is 8. What's the 4 telling me? The radius. And I don't know the theta, but I've got an equation that relates all 3 of those. So I'll substitute in. Area equals theta times r squared divided by 2. Good morning. Yeah. I'm giving notes. Does he want to leave? Axel, do you want to leave?
Well, I can finish this first.
Oh, I don't know. He's going to finish, he said. I think so. Oh, he looks pretty good. You going to make it back there, Axel?
Yeah.
Oh, he's good.
Not first.
Okay. Bye. Call your mom when you're done.
Yeah.
Okay. Here we go. 8 is the area. We don't know theta. We do know the r. And I'm going to divide by 2. Substitute in. So far, so good. Now we just got to work some of this stuff out and do some algebra. Okay, I'm going to do the 4 squared and divide by 2. What's 4 squared? Divide by 2. That all turns into 8 right there. So this becomes 8 times theta, or theta times 8, whichever way you want to write it. How do I solve for theta? Divide by 8. Theta equals 1 what?
Radian.
This is a radian. Remember when my formula starts with radians. So this is a radian. What did I ask for? Degrees. So can you get from radians to degrees? Yep, so it's just divide by pi times by 180. If I remember, I think that was around 57 degrees.
Yeah.
So you just take care of the degree part at the end. We're just about there. We may call this one the last one. Yeah. Finding r, we've got a pi over 4 and 36 square units here. Is that almost theta or is that theta? Why is it theta?
That is theta.
That is theta. Why is it theta? How do you know it's not a degree? Doesn't have a little degree mark by it. If there's no degree mark by it, that has to be a radian. So that is theta. We don't know r, and the 36 square units is a. So we substitute in for the parts we know. We know the a is 36. The theta is pi over 4. The r I don't know. And anytime I have a fraction, I don't like to introduce another fraction by dividing by 2. I like to just multiply by what?
Reciprocal.
1/2. To me, it's just easier that way to keep everything straight. Because divide by 2 is multiplying by 1/2. Same thing. I'm going to put that r squared over 1 so I can see everything that's lined up. Anytime I have one fraction, I like to make everything fractions. And I can see where my numerators are and where my denominators are. Okay, you got a couple options here. I like to combine my constants first. So I'm multiplying pi times 1. So I'm going to keep the 36 there. So I get pi over, my denominators all multiplied together give me 8 times r squared How do I get rid of that pi over 8? I like to multiply by the reciprocal. And the reciprocal would be 8 over pi. So I'm going to multiply this by 8 over pi. So I'll stick a 1 under the 36. Gone, gone. I've got r squared. I'm going to have 8 times 36 over pi.
288 over 5.
288 over pi. And you can divide that out if you want. But then how do I get r? Yes. Square root and we'll have your answer. God, my notes stress people out today. Trig on Monday, page 120. I don't know, I'm not a calculator.
I got 9.58. That's 5. Yeah, but you have to round, Katie. I don't know if it's no, there isn't. There's 7 after 7.
Why is mine different?
I got the 4.
It depends on whether you use pi or whether you use 3.14.
What's the answer?
Around
9.57.
9.58. Nobody counts. 9.57. Okay, I'm not sure.
Oh, I gotta stop this.